What is mathematics, if not doing things that were impossible until recently?
Our job consists in taking things to the limit, hand in hand with intuition, creativity, and of course, lots of coffee. Welcome to the IFIP TC7 Conference on System Modeling and Optimization, organized by the Research Center for Mathematical Modeling MODEMAT and the Ecuadorian Mathematical Society. What we do at the center is precisely building innovative mathematical models to solve problems from different application areas, while at the same time, the scientific findings are presented in international conferences and published in top scientific journals.
As we are used to in our science, everything seems impossible at first, often even unnecessary. Who's interested in a state-of-the-art research center located in a small country in the Latin American Andes? Doing scientific research in applied mathematics? Impossible. And with effort, MODEMAT was born in 2012 through an agreement between the Escuela Politécnica Nacional del Ecuador and the Secretariat of Higher Education, Science, Technology and Innovation, CENESIT, with the commitment to consolidate research in applied mathematics as a cross-cutting support for development of other scientific and technological areas of strategic importance for the country.
What drives us?
The sense of purpose.
If we think about the legacy of what we do, it will not be the hundreds or thousands of calculations we perform.
It won't be the hours we spend in front of a piece of paper thinking about a proper model, a proof, or an algorithm. It will be the difference we can make to build scientific capacity, to establish research networks, to improve people's lives. In contrast to former times, we now have graduate students and postdoctoral researchers working hand in hand with established investigators, providing scientific solutions to relevant problems of the society. Mathematics indeed can make a difference.
One of the projects I worked during my doctoral studies has to do with the estimation of rheological parameters of volcanic flows. Ecuador is considered a country of high volcanic risk. Therefore, in order to minimize this risk, it is necessary to study the properties of lava flows that are emitted during these events. Due to the difficulty of being able to track these events in real time, estimating the physical parameters that dominate this behavior is still a challenge in current volcanology. By using segmentation algorithms on high-resolution thermal images, along with inverse problem modeling, it is possible to estimate these parameters.
Since 2013, the Research Center for Mathematical Modeling, MODEMAT, has been in charge of building a numerical weather forecast system for Ecuador. The problem itself is challenging because numerical weather prediction is based on modeling the conservation laws of the atmosphere. Additionally, in the Ecuadorian case, we need to consider the difficult topography of our country, which goes from the sea level to very high Andean mountains. Consequently, we have to deal with the steep gradients on the atmospheric variables. Mathematically, we face an initial value problem. Therefore, having a good estimation of the atmospheric initial condition is crucial. To get this, we use variational data simulation methods. Due to the large scale of the problem, it has to be solved with the aid of a high-performance computer and with a specific software, such as WRF. We may use of our Kinde cluster to run the forecast.
Kinde. This supercomputer consists of several powerful interconnected servers within a high-speed network running a Linux-based operating system to provide computational resources to users from all around the country. Researchers, teachers, and students run their code remotely to process and store data that would not be possible on a regular computer. The output is usually data from high-level precision simulations, which are further analyzed to discover new information. It is an essential tool to assess mathematical models coming from a vast diversity of practical applications. The impact of such computational capabilities translate into an increasing use of mathematical models in the engineering departments, more numerical simulations projects to predict new phenomena, and more publications in the area.
When the COVID-19 pandemic reached Ecuador last year, several researchers and collaborators at MODEMAT joined efforts in order to contribute in the control of the disease. One group of colleagues has studied models of the disease dynamics, which are applied to compute effective reproduction numbers at the province level on a weekly basis. More than 100 reports have been produced up to date. Data provided by the health agencies is used for estimating problem parameters by solving Bayesian inverse problems. As a result, risk maps for COVID-19 are computed at the canton level. The Pan American Health Organization has officially recognized this work.
Our goals at MODEMAT connect us, motivate us, push us to make a difference where necessary, in industry, in the public sector, in society.
I learned about MODEMAT about 10 or more years ago, and for me it was a true discovery. I was very gladly surprised for finding such a thriving center in Latin America. It is unique in Latin America in its specificity, where the mathematical modeling is oriented to the numerical part.
Another strength is its very encouraging and fruitful collaborative environment. MODEMAT is so productive in terms of research output and in terms of output of excellently trained young mathematicians, because it creates this inclusive and genuinely curiosity-driven atmosphere in which everyone supports everyone else, and researchers are driven by their passion to make progress and answer open questions. It also is a research center that really cares about local problems in Quito, such as the work of MODEMAT for improved weather forecasting.
And today, we can say that MODEMAT is a mature research center, and the fact that the IFIP TC7 conference has been organized this year by MODEMAT is an acknowledgement of its position as a relevant international pole of scientific research in applied mathematics.
This will be a conference where, despite the distance, we invite you to dream, to celebrate, make friends, or meet old friends. In any case, I would like to invite you to come and enjoy Ecuador. Come, visit Galapagos, discover the Chimborazo, which is the closest point to the sun. And then, come to MODEMAT. It is something you have to see.
As we know, mathematical models are not just equations that we jealously keep in some notebooks. Mathematics change and shape our view of the world. They allow us to go beyond intuition and explore territories that are not yet within our reach, from anywhere in the world, in this case, from the equator of the world.